everyone, this is Walter, and we're going to be doing the problem from the review packet. It's the velocity versus time one, and the question is, make a velocity versus time graph of the following scenario. Starting from rest, a cheetah accelerates to 4 meters a second in 5 seconds, and then maintains a constant speed for 4 seconds. She then gets tired and comes to stop after 3 seconds. She rests for 4 seconds, sees a gazelle behind her, and sprints after it, reaching a speed of 6 meters a second in 2 seconds. She runs at a constant speed for 7 seconds, and then comes to a stop in 3 seconds. So that's a lot of information, but we can do this, and I believe in you guys. So we're going to start with the velocity versus time graph, because it's the best way to start, and we can get more information from it. So let's start. Okay, so let's read the problem. So starting from rest, the cheetah accelerates to 4 meters a second in 5 seconds. Okay, so it's going to take 5 seconds for it to go to 4 meters a second. Now, since it's accelerating, the velocity is going to get greater. So it's not going to be constant because it's an accelerating velocity. So it's going to be like right over here. Draw that in. Okay, so we got that first part. So, and then maintains a constant speed for 4 seconds. So it's going to go from here and it's going to stay the same for 4 seconds. So 5 plus 4 is 9. So 9 right here. And it's flat because it's a constant speed and it's not changing. Right? Okay, so then she then gets tired and comes to stop. So the wording is a little weird here, but comes to stop is basically meaning she's decelerating. So she then gets tired and comes to stop at the 3 seconds. So 9 plus 3 is 12. So it's going to go to 0 velocity in 3 seconds. Let's draw that in. Okay, so here's how it looks so far. Let's quickly review. It's accelerating, which means the velocity is steadily getting greater until it reaches 4 meters for 4 seconds. Then it's constant, so it's staying the same, and there's no acceleration, and then it's going down because it's coming to a stop. Okay, so now let's look at the next part. She rests for 4 seconds. So for 4 seconds, the velocity is going to be 0. Let's draw that in. Can you see that? Probably can. Then she sees a gazelle behind her and sprints after it. So far we've been calling like forward as positive, but now she's seeing behind her and sprinting backwards. So now she's going backwards, and now she has a negative velocity. That's because we define this as positive, and since she's going this way, it's now negative. So she rests and sees a gazelle and sprints after reaching a speed of 6. So she's accelerating here, and she's reaching a speed of 6 meters a second in 2 seconds. So at 18. And now she's accelerating. Okay, that makes sense. And then she runs a constant speed, so it's going to stay the same. So 18, 25. So it's going to go right here. And then comes to stop. Remember, the wording here is that it's decelerating when it says come to stop. So it comes to stop after 3 seconds. So at 28, it's going to go to 0. Okay, so that's it. That wasn't that bad. So now we can take this information and make a position versus time. So how do we do that? So we can split it up into its parts. So here she was accelerating. Here she was decelerating. Accelerating. Remember, when it's going down, it's getting a greater negative velocity. So she's accelerating here, and then she's decelerating here. And remember, we can find the displacement, so the change in position to make a position versus time graph. And remember, we can make the assumption that she starts in position 0 by finding the area underneath the velocity versus time. Okay, so this is 5 and this is 4. So this is going to be 20. It's going to be a positive displacement of, let's see, what's the unit? Oh, I forgot units, sorry. So velocity is meters a second. This is a second. So 20 meters. Because it 5 times 4. Okay. And then over here, yeah, that's right, yeah. Oh, I'm sorry. It's a triangle, so we divide that in half. I'm sorry, I knew something was wrong. So when we find area, it's gonna be the same thing as math, so we're gonna have to divide in half when it's a triangle. That's because it's not actually at 4 meters a second the whole time. So now here it's gonna be 4 times, 4 times 4, so that's 16, so it's gonna be 16 meters. Remember, it's still positive. And here it's decelerating, so this is 3 times 4, so this is 12. Remember, it's a triangle, so 6 meters. Okay, and here it's going to be 0 meters. Oh, now here it's going to be negative. So once again, we do 2 times negative 6, and we divide that in half, so it's going to be negative 6. So now the displacement's going down. And then here, it's going to be 7 times negative 6, so it's going to be negative 42. And here it's going to be 3 times negative 6. So 3 times negative 6, and then we divide by 2. So it's going to be negative 9. Okay, so now we can draw this out. And now it's pretty simple to draw it out. So here we have a position versus time. I'm just going to keep that right there so we can refer to it. So if we look at a position versus time graph, we can easily make this. So let's first put down the points. So here it's going to be plus 10 meters at 5 seconds. 5, and that's going to be right here. It's going to be plus 10 meters. Right. So I'm just putting down the points, and we'll draw the lines later. So then after 4 seconds, it's going plus 16. So then it's going to go 26 after 1, 2, 3, 4 seconds. Okay, so now it's going to go plus 6. It's going to go plus 6 in how many seconds? 1, 2, 3. So plus 6, so over here, 1, 2, 3. It's right there. And now it's going to stop. So it's going to be 0 for 1, 2, 3, 4. So 1, 2, 3, 4. Yeah. Okay, now it gets interesting. So now it's going to go negative 6 and 2. So it's going to go from negative 32 back to 26, but in 2. So it's right here. And then it's going to negative 42. So, oh my gosh, 26, 42. Probably going to mess up this math. So it's going to go... Okay, so then it's going to go 26 and from 26 to 42, so we can do 26 plus negative 42, which equals negative 16. So it's going to go negative 16. Let's make sure we're lined up. And how many seconds? In 7 seconds. So 1, 2, 3, 4, 5, 6, 7. Okay, so now it's going to go negative 9 in 1, 2, 3. So it's going to go to negative 25. 1, 2, 3. Hey, look at this. We're basically almost done now. So now we can just connect the lines. So here, as we see in the graph, we're accelerating. So since we're accelerating, the change positions are going to get gradually steeper. And here we're going to maintain a constant speed, so it's just going to be a straight line. So it's going to, it's going to maintain a straight line. So here it's decelerating, so it's going to get a constant slope off. And here it's 0, so it's just going to... And here, it's accelerating in the negative direction, so we're going to have like a big increase, so the change of position is getting greater. That's going to be constant up into here, so we continue this line. Remember, we have to continue the line. It's not create a new line because it's doing it at this constant speed at the very end. So we can connect those. And here it's decelerating, so we slope off. Wow, okay, so we just finished. So let me put that in the frame. I'm sorry, that was out of frame. So we basically have just finished. And see, it's not that bad. And I hope you do well. And Mr. Snowman has a little tip. So you guys are going to do great. And happy holidays. Okay, have a good day.